Welcome, Satvik, to Dayanand Sagar College and to the Department of Management Science. We have the first year students attending this lecture, and I'm sure they'll benefit immensely from your experience as well as your wisdom. I have to call it wisdom because knowledge is now has gone to the wisdom level for you. Uh, uh, Welcome, and I hope our students will really get to know much more than what they have already learned. Over to you.
Hello everyone, can you confirm that you can hear me? Okay, so I don't get any feedback from the classroom, but if someone can unmute that device and tell yes, then I can continue.
Yashwant said yes,
Yes,
they
sir.
are raising their hands.
Yes, sir. Yes, sir.
Satvik.
Okay, then I will start sharing my screen. Can you guys see my screen?
Yes, Satvik, go ahead.
Can you guys see the presentation on my screen?
Yes, we can.
Okay, so I will present like this because I want to type some stuff if required on the text. So don't mind me opening into the browser. But anyways, uh, yeah. Anything? Does anyone want to say something?
Oh, Satvik, please go ahead.
Yeah, okay. So if anyone wants to say something, please feel free to interrupt in the middle because I cannot see you when I'm presenting. Unfortunately, I'm at home in Bhubaneswar right now and I don't have my usual setup. So we will have to do with what we have. But anyways, my name is Satvik and I come originally from Bhubaneswar. Currently, I'm residing in Belgium and I'm working there as a data scientist. I used to work as an engineer in the Indian Space Research Organization, and I was posted in Bangalore for 7 years. And during this time, I met Gopal sir, and I did a course under him, which really helped me to set a path that led me to doing my master's in data analytics and now working as a data scientist as well. So in this event, I know it's Friday evening. You must guys have had a long week ahead. I'll not take a lot of your time, and I really hope that before you go out and face Bangalore traffic, you have a productive session here. But yeah, so the topic that we have at our hand is machine learning in business. Um, I work as a data scientist, and machine learning is just one of the things that I do. But I will try to tell you in general about how ML fits into the business world. And I would also like to give an impression of when you go out, like after your MBA and you join the business world, what will be expected from a young graduate like you, because the landscape of the business is evolving quite rapidly, particularly in terms of what data is available and particularly in terms of how the data is being used for decision making. So a lot of the human intuition and ideation is now being, you can say, corroborated and in some cases even taken over by data analytics. So it's quite interesting. So what exactly is the meaning of okay, this is just what I would like to say. So the first half would be like an introduction, then I will talk a little bit about what are the different kind of roles that data scientists do, or you can say roles in the field of data. Then what is the typical process or the workflow involved in a data analysis or data science project, and in the end I'll give some generic advice or some generic GAN which I hope will help you. So, okay, so let's begin. Anybody has any questions so far? You have to interrupt me because I cannot see you. So just interrupt me whenever you have a question. Okay.
Sure, Satvik, go ahead.
Yeah. So what is machine learning? Now, there are two ways in which we can teach something. Just assume a very simple example that like you want to learn how to make tea. You don't know how to make tea. Now, one thing is that you can ask your mother how to make tea. She will tell you, okay, take water, add tea powder, let it boil, add milk. She will give you the steps. So finally, it is training the tea and having it. Or you can watch your mother make tea maybe 100 times, and then you can deduce, okay, how to make the tea. So the first part is what we call as algorithms. When you are given a step of instructions and you follow that instructions to get to a certain result. So it's human engineered learning, you can say. And the second part is what is machine learning, where you give a lot of data to a machine, and then the machine, by repeatedly looking at it and looking at the labels and finding relationships and patterns in the data itself, learns to make the decision. So you learn to make tea by observing rather than asking your mother how she made it. So this is machine learning in a nutshell. Like, you can read any fancy definition. I have given some definition here, and below every slide, I will send the slides to Gopal sir. You can collect it from them. So below every slide, I have given some links and some resources which I have used to collect data. Please feel free to go through those links because they're very interesting, and they will have more value than just this 30-40 minutes of what I'll be talking. Anyway, so once we have this context of machine learning in our background, let's see why we do machine learning. So there are a lot of applications of machine learning. I'm sure you guys must know about fraud detection, where we give a lot of transactions and label the transactions as fraud or not fraud. And then the computer, when you give it a new transaction, can make out whether it's fraud or not. Similarly, if you give it a lot of customer data, it will group similar customers into clusters, and that's called customer segmentation. And it helps you to make a marketing plan or make a discount plan or something like that based on that customer. So you can attend to different customers in a more customized way. Next one, for example, predictive maintenance. So you get a lot of time series data from the machine and you analyze them and you predict when you can schedule a maintenance of the machine, because of which your downtime of machine and stuff is controlled. So this will be something that will be very useful for people who are going into operations and stuff like that. Then again, process optimization. So this process optimization part, we generally do not study under machine learning, but it is, again, for me at least, mathematically it's in the same ballpark, where and this is something most useful in business, in my opinion, because be it optimizing the price of your products, or be it finding the best schedule in which to manufacture the products, or finding the best amount of demand that satisfies all your constraints, process optimization is something that's very essential. So these are some of the applications. I'll not bore you with that. I'll directly go to, like, in my experience, why a company or a business feels the need in today's world to deploy data or to employ a data scientist in order to analyze and give them some insights from the data. Like a traditional method of this is that, for example, if you go and speak to the sales team of a company, they will have a lot of intuition about, okay, this product, if you are selling to this customer, we should sell it at this, because traditionally they have brought at this price always, our competition price is this and this. But the more we ask humans to repeat their steps, the more is the chance of errors and reduction in efficiency and accuracy, because humans, albeit very smart, they always uh, err, because to err is human. And by automating some of these steps that humans do, which don't really require a lot of expertise, for example, we can increase the efficiency. Like, we can automate a lot of process that are manual. We can improve the accuracy because a lot of the error prone steps are automated, and we can ensure that the same results are delivered day in and day out. So these are some of the typical advantages. And because today companies, irrespective of what they are manufacturing companies, they're service companies, they're in the agricultural field, they're in banking, because the world is so tech driven that doesn't matter what is your business, you are generating a lot of data. And if you are not making use of that data, you are somehow missing out, because you are just trusting your instincts and you are not really corroborating your instincts with that data. So businesses are increasingly feeling the need to look into the data that they have gathered, to look into the competition data, to look into the market data, even in some extent like climate data and so on, and to make sure that they're making the best decisions. And the young graduates that they're hiring, they're increasingly expecting that these young graduates will be able to help them in this activity of making the best sense out of the data, or drawing the most significant insights of the data. So you guys, even if you are not hardcore data scientists, if you will be working in the business after doing an MBA, and when you will be working in the business, the knowledge of data, the knowledge of how to draw insights from the data will be very important for you. Another thing that I feel is that I have highlighted here, which is personalized solutions. It is quite related to customer segmentation, as I had mentioned earlier. So, for example, in customer segmentation, what we were doing was that we were segmenting the customers, right, into different categories, and then we could tailor our programs or our say some, for example, a discount plan or something to these different customer segments. Now if we did not have this kind of a customer segmentation, or we just segmented customer based on some intuition rather than some actual data, then this kind of segmentation and this kind of customized offerings would be wrong. The same thing you can think about when you open Netflix or YouTube. It gives you recommendations that are tailored for your requirement. This is something which is called personalized solutions, right? And this personalized solutions will not be possible without somehow deploying machine learning. And the last point, which I feel is very important, is customized horizons. And customized horizons are something that comes from my personal experience. This is something that I put because when I joined my company was not very savvy. They were obviously tech savvy, but they were not very invested in the field of analytics or machine learning. But once I started working on some small models, and I'll give you a small example where I built a model for them which took their weekly demand and divided it into different daily buckets. So we had, like, for say 1,000 products. For each product we had some demand that we had to produce in our factory. Now this decision is made based on demand, but we are having so many machines that produce that product, and those machines have limited capacity. The stock of raw materials and so is limited. Our employees have certain shift plan. There are downtimes and so on. In order to optimize all these things, we created a program that was able to tell, okay, this is the number of pieces that you need to produce on day 1, day 2, day 3, day 4, day 5, day 6, day 7, so that your resources are distributed uniformly, are used optimally. And this is something that our company found very surprising, that could be done to such efficiency, and the results were seen. And then the business people themselves came up and started asking these questions, that can we do this, can we do that? And just by demonstrating one example, they pushed their horizons of what they knew, and they were able to ideate and get more ideas. So this is again one of the expectations that will be there from you, to push the envelopes of traditional methods of doing work. And when you are able to draw insights from the data and are able to provide such insights which are not possible from traditional sources, then you are actually forcing your business to push the horizons of that knowledge. Next is, what are the main challenges that we face? Obviously, when we are doing some kind of projects in the university, we get very beautiful looking CSV files or Excel files. We put them into some software that analyzes the data and gives us the result. Unfortunately, in the real world, it doesn't work like that. For example, you can still get data in as an Excel file, but there will be a date column, and if the date column has say 50,000 rows, then out of that, in the middle, some random 4,000 rows will have date in a different format, or will have some missing values, or will not have date values at all, and somebody has just joined two different tables with different values in the date column. So one of the major activities that you have to do, even though you are not data scientists or an analyst, is to make sure that the data that you generate, the data that you store, is in correct format, and then you are able to read, understand, and interpret the data properly. So this is something that's very fundamental. So whenever, I mean, in today's world, doesn't matter what you're doing, you're working in operations and sales, you're working in marketing, doesn't matter where you're working, you are generating as well as working with data. So make sure that when you are working with data, don't blindly work on it. Just look at the quality of the data and understand the data properly. One biggest challenge we face in machine learning is about interpretability. So, for example, we developed a pricing software for our business. And what it does is it takes a lot of parameters as input, and then it suggests a price, right? Now, when you give that price to the salespeople saying that, okay, you have to sell it at this price, they will ask you why. They will ask you, how did you arrive at that price? They will ask you, what does this price mean? You can go back and you can show some fancy equations that helped you. Now they will ask you, why did you write this equation? Have you considered this? Have you considered that? Often there is this issue that a machine learning is like a black box, right? So if I can write something here, maybe, yeah. So you have a lot of data, then you are pumping it into some ML model, and then it is giving you some results, right? Now, this ML model part that is here, this ML model part is often like a black box. It just It's somebody, some engineering geek has designed something for you, you are using that, and you don't really know how you got that result. And if you don't know, maybe it is okay when you are doing some kind of project for your own, but in a business environment, a lot of people's decisions and a lot of people activities depend on these results. So they really want to understand what this model did in order to get these results. So the understanding of the relationship between the data and how the results obtained are very important. And that's one of the reasons why your technical fundamentals, if you are using machine learning, needs to be a bit strong. Another big issue is about the knowledge gap, because often the people who design the machine learning models or the solutions and the people who are in the business domain who are giving the requirements, they often don't speak the same language. Like for example, I am a data scientist and I do some activity for people in the production. Say I'm making a planning software for the people in production which decides on what is the quantity that they should produce, right? Now they will tell me in a language that's a planner's vocabulary, right? But I have to understand, and I have, as a data scientist, have to transfer that explanation in English into some mathematics. Then I have to write a code which understands that mathematics and executes. Then I have to convert the results of that code into some mathematical equations or some mathematical formulations, which has to be translated into English and provided to the people in the business. And this whole loop includes a lot of Chinese whispers in a technical jargon. So one person tells someone else, he understands something, he translates to other person, and there is a big risk that a lot of information get lost in that. So as youngsters who are going into this new data driven world of business, which is still in many ways trying to figure things out, you will need to make sure, it would be your responsibility and be one of your biggest challenge, that you kind of bridge that gap between a person in the traditional business domain who is doing work in a traditional way and the IT and the machine learning engineers who would be using all sorts of algorithms and machine learning tools, but would not be understanding the business properly. So you have to make sure that you make yourself qualified and competent enough to bridge that gap in either roles. Maybe you are in a data science role or you're in a core business role. If you have the knowledge and the aptitude to bridge this gap, it's awesome and it would really help you a lot. Okay, now some cautionary tales, because um Gopal sir really wanted me to tell you some stuff that will be a reflection of why theory is important. Okay, so I've tried to give you some cautionary tales of how, if your fundamentals are shaky, then it's, you will make mistakes while interpreting data. Okay, so the first thing is like mean versus median. Okay, so say 10 of you like graduate and you go out some to some restaurant, and you are having dinner, fancy dinner, and you guys are discussing about what salaries you have scored. And say if on a graph I plot you, you are 10 people, so all your salary is something like this, and you get, okay, the average salary now would be somewhat, because all of you have gotten more or less within 5-6 lakhs of each other, so the average salary is around 50 lakhs for all of you. Okay, now Elon Musk comes into the room and he sits in your table, and all of a sudden there is one data point somewhere here. No offense, maybe some of you are close by, but assume that all of you are typical students. And then if I take an average, the average will be somewhere here. Now, this average value is nowhere representative of the average income of the whole population, right? Like if somebody sees the average income of this, if the first instinct is that, okay, more or less everyone in the population has an income of this, but that is not the true representation here. If, however, I would have taken a median value. Yeah.
Guys, go on
Can I-
mute, please.
Yeah. So, however, if I would have taken a median value here, my median would have lied somewhere here. And that would probably have been a more truer representation of what is the population of most of the people, because that's what you really want to know when you talk about an average population. And this is one of the things that you will see politicians making mistakes most of the time. Why? Because it suits their narrative, to be frank. Now, if we go to correlation versus causation, this is another classic cautionary tale where things can go wrong as a data scientist, because often we are very so correlation is quite easy to find out. So people jump to the conclusion as this has caused that, right? So for example, there is a survey that says that, okay, old people are bad at technology. Why? Because they plotted the age of the people and they somehow managed to measure some coefficient of tech savviness, how tech savvy people are. And when they join, they clearly see that, okay, as age increases, the scores actually decrease. So younger people are better at technology and poorer people are bad at technology. So they could see there is a clear correlation. It has a decreasing trend. And yeah, easily we can say that, okay, old people are poorer. But if we start including some confounding factor into this, like we tell them that, okay, take the age at which they were introduced to technology, take the number of years they have been exposed to technology, at when they were young, what kind of things were available. So there are a lot of confounding factors that you can take to this. And then you will understand that age alone does not mean that older people will be bad at adopting technology. No, it simply means that maybe they were more recent adapters and they were more, you know, there are a lot of other factors that are challenging. Maybe they don't have the same access to the technology, the people in the survey, and so on. So you always have to take this in mind, right? Like what kind of population is your survey and stuff based on? So particularly for people who are going to work in marketing, but particularly marketing, you guys do a lot of survey. Like the marketing people, they go to customers, they ask about their preference and so on. And if your population is not, like the survey sample is not representative of the population that you're doing, it is very easy to make sure that you'll see something as correlation and you've not considered any confounding variables. You assume it as causation, and then you launch some kind of a scheme that doesn't really work well. So keep always this thing in mind, that correlation versus causation, they are not the same thing. The other thing quite interesting is survivorship bias. Again, I'll give you one small example. Say that a student in a university wanted to do some kind of thesis or something, and for that thesis, he wanted to show that smoking was actually injurious for health. So the best way that one can do such an experiment is that have a sample, representative sample of around say 1,000 people, uh, and another represents, so have two samples of 1,000 people each. To one sample you tell them to smoke for 20 years, to the other sample you tell them to not smoke for 20 years, and after 20 years you measure some of the health parameters in the duration of 20 years. And if the health parameters of the smoking population is actually statistically significantly different from the non-smokers, then you say, okay, smoking is injurious. But this is also unethical. I cannot simply randomly choose 1,000 people and tell them to smoke for 20 years knowing that it's going to cause some harm. So what he did is that he came to know that in his university there is a get together. There is a get together of people who graduated 20 years back. So he had this idea that, okay, I can just go to this get together and I can check the health of different people and I can ask whether they smoke or not. And he did this. He went to that get together. There was a good turnout of around 1,000 people. He measured everyone's health parameters and he saw that, okay, there is not a lot of difference between people who are smoking and people who did not smoke. So he published his results saying that, okay, the people who smoke and the people who don't smoke, there is not a lot of difference in that. So this claim that smoking is injurious to health is actually quite rubbish. Now, it is a published paper. He had data, he had evidence and everything. But it is not right? Because the people who came were the healthy people. The people who are actually sick did not turn up to that get together, because no sick person is going to attend and get together out of nowhere. So he, in his what we say, in his enthusiasm to get results, he went and he surveyed a completely wrong sample, and he surveyed only the people who are already healthy. And doesn't matter the people who are already healthy, if they are smoking or not smoking, they're already healthy, right? Maybe the people who actually smoked and got sick, they did not turn up, so he didn't get that data at all. So this thing is called survivorship bias. So make sure again that the sample that you're checking, there is another very famous story where a lot of planes that were crashing in World War II in Britain, they were seeing where to reinforce the planes so that other planes don't get shot. So the planes that were landing, they were looking at the bullet holes and they were saying where there are more bullet holes. So when they asked a statistician about this, he said, no, the place where there are bullet holes, these planes have survived. So the place where these planes are not hit are actually the places which are more dangerous. So you should actually put more armor in the places where these planes are not hit and not in the place where these planes are hit. So survivorship bias is a very interesting topic that you will see again and again. And if you are aware of this concept, you can take some kind of precaution when you are analyzing data. And in the last, like there are wrong matrices which you should be careful of. So for example, I build a machine learning model that dictates fraudulent transactions, right? And my idea is that any transaction that is given, I will say that yes, it is a fraud. Okay. So now, and my metric to use it is that how many fraudulent transactions have been detected versus how many fraudulent transactions actually existed in the sample. Now, if my model always predicts fraud, then it will predict fraud when the transaction was non-fraudulent, and it will also predict fraud when the transaction was fraudulent. So if I take only this matrix, which is often called as accuracy, that the number of transactions detected by number of actual transactions, it will always be 100%. But just if I change this and I say, okay, number of non-fraudulent transactions detected by number of non-fraudulent transactions that existed, in that case it will be 0, right? So it is very important to choose the metric very correctly of what you are doing. And if you don't choose the metric correctly, then a model that you feel is performing really really well actually is not going to do much in the real world. So these are the four like cautionary tales I wanted to highlight in order to say that okay, these are very basic and simple concepts, but often data scientists and business people, they make a lot of mistakes in these things because it's very easy to skip in your enthusiasm and in your pressure to deliver results. You often miss these things. But when you are actually going into the industry or even in your university, when you're trying to do data projects, try to be try to have like an open mind and try to judge the projects properly, try to judge your problem properly. Okay, I'll skip this. Now let us quickly go because we are kind of running out of time. So I will quickly talk about a little bit about what data roles are like in the industry. What are some of the roles that people typically do in the field of data? So I read a little bit about this and spoke to my friends and all. So there are three basic roles that you have in the data. One is engineering, one is analysis, and one is product management. So all the roles revolve more or less around these categories. So the engineering team roles, they basically store the data, they build the data models, they build the data warehouses, and so on. I'm not sure these are the kind of roles that any of you would go into. I believe that you guys will mostly be centered around these two roles, particularly these one, because these tend to be more entry level roles. These tend to be more, after you've gathered some experience. Now what happens in analysis? When you have analysis, you ask the engineer to give you some kind of an access to the data, and then you clean the data, you pre-process the data, you visualize the data, you implement some statistical models so that you can draw some insights from the data. This is the most important part actually, because you are aiding the data driven decision making in your industry. So this is the typical definition of all your business analysts, business intelligence experts, data scientists. All these people are somewhere in this genre, and this is probably one of the data roles that most of you, if you try to, would get into. The next one is product management. So there are companies which make a product based on a data. I mean, based on data. So their product is offering some kind of insights based on data. But even if it's not the core business of a company, the data science projects are managed by managers. So this can also be like some manager of a data project. Okay. Sorry, I'm writing with a mouse, so it's pretty strange. So it's mostly about managers. So what these people do is they are aware about the data projects, overview of data projects. So they understand which kind of data we should access, which kind of technologies we should use. They will manage all the data scientists and business process experts in their team, and they will make sure that the requirements that are captured and the sprints that are going on in order to draw the insights from this data is done in a proper way. So most likely some of the data scientists and all, they move or they graduate into the position of a manager after some time, and then they manage a number of data scientists. So these are mostly the three main roles that are available in the industry, and any role that you see in the market will be one of these. This was just for you to have an idea, so that when somebody tells you, you can easily segment that in your mind, and okay, this is for analysis, this is for engineering, okay, this is more of a management thing. Okay. Okay, there's one more point here. Even like there is a role which somehow is there in this intersection, which is also very interesting. This is in the intersection of these two. It is also very interesting for MBA students because it is something that they call as a business analyst in most of the time. And the role of a business analyst is often to take the requirement from the business people or from the clients and to convert it into some form of a problem statement that aids the data scientist to solve it quicker. So as I said in the beginning, right, so I have people who are working in production and they tell me their problem in their own terms. Now I have to understand their problem, I have to translate that problem into a data science problem, then I have to mathematically model it and so on. So there are people in the industry who are experts at this translation, right? So they form a very nice intersection, or you can say a liaison between the data scientist or the data team or the IT team and between the clients or the business process experts. And this is also one of the roles that can be very interesting for you, particularly if you have the business process expertise, being an MBA graduate, and also inculcate some of the data literacy in you. Now, before we go to the last part, I'll just quickly in 5 minutes tell you something about what is a data science workflow. So when I'm not sure if you guys have done any kind of data projects yet, but whenever you get any kind of data project, right, to start with, a data project is kind of a misnomer, in my opinion. You're always trying to solve a problem. So, as a data scientist or as somebody who is working with data, the first step should always be to spend time with a business process expert or anyone who's come to you with that problem and to understand first what the problem is. So, if somebody is wanting you to build a pricing tool, for example, so what he is actually looking for, he is saying that, okay, if I have a product X and I have a date D, give me a price P for this product on this date. Now, this is his problem, right? Don't ask him what data and everything in the first step. Try to understand the problem. Once you understand this problem, fix an objective. Okay, so my objective is to give a price of a certain project, of a certain product on a certain date. Now you try to understand how they are defining it today. Maybe they have some methods, some expertise in order to find that out. Okay, now what are the data that you're generating? Okay, they will give you a product table with all the product data, they will give you some customer data, they will give you historical prices. Okay, great. Now with all this knowledge, you try to see and analyze the current data and see whether what they are explaining, their process, what they are doing in order to get this price, is it actually true? Is it actually matching based on the data? After that, the next step should be to fit some kind of a machine learning model or a statistical model, because by this point your understanding of the data is very good, your understanding of the process is quite good, you have a good rapport with the business team. Now you start to deploy some kind of machine learning model, statistical model on the data and draw some insights. Now you give those insights. Now there is an iterative process where you give your insights, the process experts, they validate that, they give you some comments, you tune your model again, you get some more results. Now there is an iterative process, and finally you land in some kind of a solution. And then you can build, like, it's most of the engineering work after that, because once you have provided them a solution, then the engineering team will build like an application for them to deploy your model and so on. But these 4 steps are a typical workflow of any data science projects, and it is very important to keep in mind that it's always, as you'll always feel very enthusiastic to jump on the data and start analyzing, but try to control and try to understand the real problem, try to understand what the client who has come to you is looking for, and based on that, with this understanding, with this rapport built with the client, then try to analyze the data. Finally, some closing remarks. I'll not take a lot of time. The first thing is, people often ask me, is coding important? So I always tell them that coding has become like literacy today. Like, no person who is joining the workforce today can claim that they don't know any kind of coding or are not willing to learn coding, right? So if you remember in the early 2000s, when people were building resume, even like in 2010, 11, they used to write Microsoft Office as one of their proficient skills. Today, it's not necessary to write because people just assume that you know that. I think 5, 6 years down the line, when people are hiring, they will just assume that they know coding, like coding in some language. And if you want to work with data, I would say Python is the most easy to learn and most useful coding language of choice. There are R, Scala, other languages, but if possible, at least have some basic knowledge of Python, at least how to process Excel files in Python and how to do some basic, linear regression analysis and everything on Python. That will really help you, and it will help you throughout your career. It's not just to get a job, but by having the skill of Python with you or any coding language with you, you can achieve so much more than the people who are scared to do coding. That will really propel your career. And particularly in country like India, where it's so competitive, it will really help you. The second thing is, do we need to know a lot of statistics? Not a lot of statistics, but you should be familiar with statistics. See, all these examples I gave you earlier in the cautionary tales thing, they're basic statistical concepts, right? Mean, median, correlation, causation, guessing the right metrics, like what to use. These are very essential concepts, not only statistics, but basic mathematics like algebra and everything. These are very basics that we studied in high school. I'm not even saying that what you studied in your engineering and so on. No, high school statistics, high school algebra will go a long way. It will really help you to perform much better than your peers. And this is not something I'm telling because I have to tell you or Gopal sir asked me to do. No, this is something that I feel now, that because I have better statistical skills and better maybe analytical skills than a lot of my colleagues who are working in the business for say 20-25 years, I have the opportunity to turn myself into an asset if I use these tools properly. And finally, if you want to go into a proper data field, the concept of databases is important, particularly a little bit of SQL in order to know what is relationship between different tables, what is a primary key, and so on. But companies who will hire you often have some kind of orientation program, and you have a lot of online resources as well today. But make sure that these are the three technical pillars that you really need when you're working with data. And then I consider soft skills to be even more important than technical skills. And soft skills in the sense, the first and the most important is empathy. Because if you don't understand the problem and the person who has come to you with that problem to solve with your data skills, then you will never be able to solve. You will always give him a solution that he does not need. And you have to empathize with that person's problem, with with the person's pain points in order to deliver the best solution to him. So empathy in my mind is the most important thing. Try to be humble, try to be open. Humility is the second point, because the moment as a data as a data person or something that they call say as a data scientist, or a data professional as they call, I think you will always have to keep on learning because the field is evolving so rapidly. So the moment you feel that I know more than everyone else, you are done, right? So always try to keep on learning, read medium articles, watch videos on YouTube. These are gateways, but keep on learning, keep yourself open to new ideas. When I used to work in ISRO, somebody once told me that, what do you know? You just have a bachelor's. Try to ditch those kind of attitudes when you go into the professional field, because even if a person is just in high school, he has something to offer you. And if you're working in the field of data, you have to learn from everyone around. And the last part is adaptability. So when you join the business today, because the technology landscape is evolving so rapidly, and even the political economic landscape of the world is evolving so rapidly, what you are hired for, what you will do immediately, what you will do after 3 years, and what will you do after 6 years, nobody knows. The playing field, the landscape changes very rapidly. You have to keep yourself up with so much today that you have to be adaptive. You have to keep yourself adapted to new change that is coming, welcoming of new change. So this is something that I would like to finish my talk with, that make sure that you are open to change, because you can get a great job, you settle in, but 6 months down the line, 1 year down the line, things will change. Things will change immediately again after 6 months, immediately again after 1 year. And you have to keep yourself more flexible in order to acquire new knowledge, in order to work with new people, in order to adjust with new cultural changes and so on. So be empathetic, be humble, and be adaptive to change. So these are my last three things that I would like to wrap up with. Thank you so much, everyone, for listening to me. I am really sorry that it was maybe quite heavy towards the end of the Friday. But all these slides I will provide to Gopal sir, and each slide at the bottom has a lot of references that you can go through. I would strongly recommend that please go through those references, because they are very, very interesting, and you will get to learn a lot. These are not technical resources. I'm not giving you any papers or any articles or technical, but they give you an idea of how machine learning world inside the business world, how the world of machine learning looks like. So with that, I would like to wrap up. Thank you so much, everyone, for listening to me. And if you have any questions, please feel free to ask me.
Thank
Hello.
you, Satvik. Questions, please.
Hello.
Hello. Yeah, I can hear you, Puneet.
Sir, can you tell us what is the current scope of business analytics internationally?
What do you mean by
Also,
scope?
sir, like opportunities. If we choose business analytics as a career,
Yeah.
can you tell us what opportunities we'll get
So,
internationally, sir?
see, the definition of business analytics is quite malleable. Okay. So, business analysts, if you look at a business analyst job advertisement from different companies, you will see a lot of commonalities, but you will also see something specific that they're asking. So, in today's world, business analysts, in earlier, if you see 5 years back, business analysts were people who are a liaison between the IT team and the client. Today, business analysts analyze the data, they make visualizations, they make reports suggesting something. They even work in consulting agencies to do that. Now, the scope of business analysts in today's world is quite huge because every company is trying to enter into the market of data. Not the market is the wrong word, but into the field of data. They are generating a lot of data and they want to analyze that data. So and those data scientists that they're hiring for their business roles like operations, sales, they often call them as business analysts. So as a business analyst, there is a lot of scope. However, in my opinion, anyone who is doing an MBA and joining the workforce after 5 years, 5 or 6 years, will have a will have a basic level of data literacy. We will be at par with the data analyst master's program people of today, because it would become so commonplace in the next 5 6 years. So today there is a lot of scope. The definition of this role will change in the future, and you will have to reinvent yourself as a data analyst professional if you join the industry today. I hope that made sense.
Okay, sir. Thank you, sir. Thank you, sir.
Sir, am I audible?
Yes, you are. Yeah, I can hear you.
Am I audible, sir?
Yes, you are audible, Samarth. Yeah.
Sir, what are the necessary skill sets that we need to have to build a career in business analytics?
Okay, so the first necessary skill that you need to have if you're looking at India is to have some kind of a master's degree, whether it's an MBA or something that tells the company that you are able to do some kind of data analysis. But what really helps is if you do already some projects which include maybe some visualizations in Power BI or Tableau, something like that, just to show them a skill that you have this. You can show them some statistical skills, like for example, if you can do some kind of projects related to data analysis in your MBA curriculum, that would be really helpful. Try to highlight those things in your resume, that you have done these projects to analyze this and find this out. Write a line about your results in the resume. Do some online courses, I would suggest, on basic machine learning. And if you have Python or R or any of these programming languages in a repertoire, just at a basic level, that's a win-win. That would be a big one as well. So yeah, to sum up, like Excel, obviously, like I don't have to say, Excel is mandatory. Then a little bit of knowledge about either Power BI or Tableau or any a visualization tool. The third point is, if you can do a lot of projects, at least 1 or 2 projects during your MBA on data analysis. And the last point, if you can learn Python or R or anything.
Satvik, actually, they do learn R and Python and Excel in their course.
Yeah.
Project on data analysis, yeah, maybe that's something which they can focus on, definitely.
Yeah, it can be something very simple, like some simple beginner level course, like a project from say Kaggle or something. You will also get the solutions to those projects, but just to practice, like there are so many data sets available today, like fraud detection data set and so on. Just download something and run some basic script on that and make sure that you get some result. But if you show more than a degree, if you show some real experience in projects, in my experience, that's much more valued in hiring than just some certificates. So yeah.
Yeah. They do a project towards the end of their, fourth, I think third semester they start, and into the fourth semester they do some internship as well as a project. Maybe they can focus on the data science. So whoever is interested in being a data scientist can focus on projects related to data. Yeah.
Exactly. And even if the people who I would say that are not interested in data related roles, it is always advisable that they have some kind of literacy of data, like how to, like I have heard from my MBA friends that when they were in their MBA education, like in 2016-17, many of their friends didn't even know about pivot tables and making pivot charts and reports. So make sure that your literacy of Excel is top notch. Like you are able to do some kind of regression analysis in Excel. You're able to do pivot tables. You're able to make reports, because it doesn't matter what role you do after MBA. This is going to be bread and butter. Even for me, a lot of my work is still in Excel. So try to make sure that your Excel skills are a bit top notch. And yeah, the theory part is always there.
And guys, I didn't ask him to tell that.
Yeah.
I teach them Excel. So you pretty much told them whatever I keep telling them in the class. So,
yeah, actually, when we were in ISRO, a lot of our friends used to tease other people saying that, hey, he is only you working with Excel sheets. But now that I am in their position, I understand what an ocean Excel is and what is the power of that tool. And like it has completely, like the world of business globally runs on Excel. Like we can talk about machine learning and everything. Even Excel has become so powerful, like Microsoft itself, the ecosystem has become so powerful that you can use AI models pre-built inside the Microsoft environment. So you don't need to know a lot. You can just drag and drop the AI model and it will allow you to do a lot of the things. Even optimization, the Excel solver is itself quite powerful. I mean, it doesn't solve everything, but it still is quite powerful to do stuff that you would need in your day-to-day business life. So yeah.
Absolutely. And I have one question. Recently, this ChatGPT stuff is becoming sort of a craze. Now, your comment on that, because people say we don't need to learn anything anymore. ChatGPT is there.
I will, what I did before preparing this presentation, I had asked a lot of questions to ChatGPT in order to make this presentation. I have copied and kept those questions and answers, and I have made a document for you. I will share that with you. You take that document and then you compare the final presentation that I have built. You will know that what ChatGPT tells you and what is the output. You can yourself compare that is the sole purpose that I have kept that. And then you will realize, so my wife, who is a linguist, actually works a lot with language models, particularly GPT as well. And she tells me that because she's teaching in a university in Belgium, and she asks ChatGPT a lot of questions in order to make her presentation. And because they're in academics, they need a lot of papers to back those claims. So she asked ChatGPT about, give me references to support this. ChatGPT gives her references, and she has 100% record that none of those references are real articles. Zero.
Really?
Zero. Not a single article so far that ChatGPT has suggested her, including DOI numbers. ChatGPT generates DOI numbers. Not a single one is a real paper.
Are you saying ChatGPT is making up all these things?
ChatGPT is making up DOI numbers.
Are you?
Zero out of. I mean, she has taught one whole course for one semester. She did not find one right paper from ChatGPT. So take ChatGPT. ChatGPT is GPT-4 is very powerful. It's trained, particularly the things that uh, organizations like Khan Academy and all are doing, which are taking the GPT model, the transformer model, and they are training it for their requirement in order to solve their problem. So the model itself is beautiful. It's wonderful. It's huge. You can read the papers. They're available openly, obviously, in archive. But for your daily requirements, like I have been, one of my projects in the industry is to see that how GPT-4 can aid our business people in their research particularly. However, it's limited in some extent because it doesn't have the latest data. It can only give you data up to 2021. I think September 2021 is the cutoff date, and so on. But nonetheless, I feel it's an advanced version of search. Earlier, if I had an intern, I asked him to do something, he would look at 10 different websites, he will organize the data into a presentation, he would give it to me and I would look at it. Today, I can ask the ChatGPT thing to do it. It will go to different websites, it will neatly make me different slides, like point wise it will give me. But it is up to me then to use that as a guideline, and then based on that guideline do my own research. So this is exactly what I did for this presentation. I asked ChatGPT something. Unfortunately, whatever ChatGPT told me was my first two slides. Then everything else I did further research to add to that. But because ChatGPT had given me such a list, it made my life much easier, made my process much more streamlined in order to finalize the final presentation. So this is how I urge my colleagues also to use ChatGPT, that without searching the web now for everything, go to ChatGPT. ChatGPT will narrow down your search horizon. Then you can go and search for specific things that will make your life much more efficient. So this is, I think, my 2 cents on this wonderful thing.
Thank you. Any other question? Shall we close then? No more questions? Satvik, that was wonderful. Thanks a lot. Please share the PPT. I will share it with the class. And I'm sure, they will go through it once again and, come up with more questions and probably try to get more answers. Yeah, use a ChatGPT also can be used now. So let them try and let them
Yeah.
more answers there. It was fantastic. Thank you so much.
Thank you. Thank you.
And,
Just one request, please go through the references that I have provided in the PowerPoint presentation. They will really be helpful. They will answer, you will be encouraged to ask more questions because of that, and it will clarify a lot of things related to jobs and future preparations, because I have not given any technical references, very basic references, but they will be quite refreshing. Particularly there's some books and stuff which are very nice in that.
Thank you. Yes, that is an important point. And, I just, a small apology. I know that we were planning to have you speak to us for a long time. We have had several dates. We missed all of them. Please excuse us. It was
Please,
beyond
it's
our
okay.
control. It was,
It's absolutely okay.
other things happened which could not, make this. We could not have both your lecture and something else together, and we didn't have control over the other things.
It's absolutely okay, sir. Like, I am, just treat me as your student still, so it's okay to adapt.
You're way beyond me, Satvik, now. Anyway, nevertheless, thank you for that. And next time you are in Bangalore, we would want you to visit our college, meet the students in person, and including the staff. We would love to have you here and host you.
I'll try to make some time for that for sure, sir. Thank you.
Thank you so much.
Thank you, sir. Thank you everyone for
Thanks,
your
everyone.
time. Bye-bye.
Bye. Bye. Oh,